Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
The presence of blue smoke in a vehicle's exhaust is often a sign of an underlying mechanical problem, requiring immediate attention. This unusual emission not only attracts the attention of drivers, but can also indicate potential failures of the engine or exhaust-related components. In this article, we'll take a close look at the possible causes of blue smoke, ranging from engine problems to fuel and exhaust system issues. In addition, we'll explore diagnostic methods for accurately identifying the origin of blue smoke, as well as practical solutions for remedying these problems. It's imperative to understand that blue exhaust smoke should not be ignored, as it can not only affect vehicle performance, but also have environmental implications. By taking a proactive approach, drivers can help prevent more serious damage and reduce their impact on the environment. This journey through the nuances of blue exhaust smoke will give us an in-depth understanding of this phenomenon, its origins and the measures needed to solve these problems, ensuring better performing vehicles and a reduced environmental footprint. Understanding blue smoke. The different types of smoke. The smoke emitted by a vehicle can vary in color, indicating different underlying problems. Blue smoke is particularly distinct from other types, such as black or white smoke. Understanding this difference is crucial to the effective diagnosis of mechanical problems. 1. Blue smoke versus other types of smoke. Blue smoke is often confused with black or white smoke. Detailed clarification between these different emissions will help drivers to accurately identify the problem with their vehicle. 2. Visual identification of blue smoke emissions. An in-depth explanation of how to visually observe blue smoke and distinguish it from other types of smoke, providing a crucial first step in the diagnostic process. Composition of blue smoke. Blue smoke is not only a distinctive color, but is also characterized by specific components. Understanding these components provides in-depth insight into potential problems. 1. Presence of gases and particles. Explore the gases and particles that give smoke its blue color, highlighting specific components that may indicate mechanical problems. 2. Environmental impact of blue smoke. A look at the environmental consequences of blue smoke, highlighting the importance of quickly resolving these issues to reduce harmful emissions. This section introduces the reader to blue smoke, clarifying how it differs from other types of smoke and exploring its composition, laying the foundations for a deeper understanding of the possible causes of this phenomenon. The remainder of this article will focus on these causes for more targeted intervention. Causes of blue smoke. Engine problems. Engine failures are among the most common causes of blue smoke. Understanding these mechanical problems is essential for effective intervention. 1. Excessive oil consumption. A detailed explanation of how excessive oil consumption can lead to blue smoke, highlighting underlying causes such as worn piston rings. 2. Piston ring wear. In-depth exploration of piston rings, explaining how their wear can contribute to blue smoke and why they require immediate attention. Fuel-related problems. The quality of the fuel used can also play a crucial role in the generation of blue smoke. This section looks at fuel-related problems. 3. Poor quality fuel. The implications of using poor quality fuel on blue smoke, warning of the risks associated with this choice. 4. Unbalanced air-fuel mixture. In-depth analysis of the role of the air-fuel mixture in the generation of blue smoke, and how imbalances can be corrected. Faulty exhaust systems. Problems with exhaust-related components can also contribute to blue smoke. This section explores these failures. 5. Faulty catalytic converters. The consequences of a defective catalytic converter on the production of blue smoke, and the corrective measures required. 6. Fouled particulate filters. An examination of particulate filters, explaining how their clogging can lead to blue smoke emissions, and possible solutions. This focus provides a detailed overview of the potential causes of blue smoke, concentrating on engine problems, fuel-related issues, and exhaust system failures. The next step is to examine diagnostic methods to pinpoint the precise source of the problem. Blue smoke diagnosis. Visual analysis. Visual observation of smoke emissions is often the first step in diagnosing blue smoke. This section explores how drivers can use this method to identify potential problems. 1. Observing smoke emissions. A detailed explanation of how drivers can observe the smoke emitted by their vehicle, focusing on the distinctive characteristics of blue smoke. 2. Differentiating between possible causes. A practical guide to visually differentiating the possible causes of blue smoke, helping to guide the diagnostic process. Mechanical testing. Beyond visual observation, mechanical tests are essential to pinpoint the source of the problem. This section examines these tests. 1. Oil consumption analysis. A detailed description of how oil consumption analysis can provide clues to the mechanical problems causing blue smoke. 2. Engine compression control. An exploration of the role of engine compression testing in diagnosing blue smoke, and how this test can be carried out. Electronic diagnostic tools. Modern electronic diagnostic tools play a crucial role in accurate problem identification. This section explores these technologies. 1. Using OBD scanners. An explanation of how OBD, onboard diagnostics, scanners can be used to identify blue smoke fault codes. 2. Interpreting error codes. A guide on how to interpret the error codes generated by OBD scanners, offering valuable information on mechanical problems. This section guides readers through diagnostic methods, from visual observation to advanced mechanical testing and the use of electronic diagnostic tools. The final part of the article will focus on practical solutions to blue exhaust smoke. Solutions to reduce blue smoke. Preventive maintenance. Maintaining a vehicle in good condition is essential to prevent blue smoke. This section looks at preventive measures that can be taken. 1. Regular oil changes. The importance of regular oil changes in reducing oil consumption and preventing blue smoke. 2. Use of quality fuels. A guide to quality fuel selection, highlighting its impact on reducing blue smoke emissions. Engine repairs. When engine problems are identified, repairs are often necessary. This section explores corrective actions at engine level. 1. Replacing piston rings. A detailed explanation of how to replace piston rings to reduce oil consumption and eliminate blue smoke. 2. Seal overhaul. The importance of overhauling seals to prevent oil leaks and reduce blue smoke emissions. Clean exhaust systems. Exhaust system components can be repaired or replaced to reduce blue smoke. This section explores these solutions. 1. Repairing or replacing catalytic converters. The procedure for repairing or replacing defective catalytic converters to restore proper exhaust system operation. 2. Cleaning particulate filters. The importance of cleaning clogged particulate filters to ensure clean exhaust and reduce blue smoke emissions. Blue exhaust smoke, common cases. 1. Lots of exhaust smoke when starting the car, not diesel. Valve seals have gone bad if exhaust smoke appears after the car has been parked for a while and the engine is not diesel. See Note 1B on diesel below. This would suggest faulty valve seals. If the valve seals are bad, oil has probably dripped into the engine while it was parked. Engines have valves that open and close. The valves are opened mechanically by pressure applied to them by a rocker arm. They let gasoline and air into the engine. They let the exhaust gases out of the engine after the gasoline and air have been burned off. The tops of the valves where pressure is applied are covered in oil. Valve seals are available to prevent this oil from entering the engine. When these valve seals wear out, they allow oil into the engine. The oil going into the engine is then burned with the gasoline and air, creating the blue smoke. Usually, the car has to sit for a while, like all day, with the engine not running for the oil to flow into the engine through the worn valve seals. Sometimes the smoke will be worse when the car is parked on a slope, as this can tilt the engine, causing more oil to end up on the worn seals. This causes more oil than usual in the engine and creates more blue smoke when the engine is started. How to repair valve seals. Valve seals are not too difficult to replace, and can be done at home by someone who is comfortable working on engines. A major concern when replacing valve seals is not to drop the valve into the engine. Some people will use compressed air fitted through the spark plug opening to keep the valve up. The difficulty of replacing valve seals depends on whether the engine has an overhead cam or not. The overhead cam will require more work, as it has to be removed to gain access to the valve stem. The aim is to remove the swing arm and get out of the valve. Then lift the old valve plug out of the valve stem and replace it with the new one. Special tools are available to compress the valve spring so that it can be moved out of the way. 1B. Diesel smoking on startup. Bad spark plug diesel engines use glow plugs at startup to ignite the diesel fuel. Glow plugs provide heat to ignite the diesel fuel. Once the engine has warmed up, glow plugs are not needed, as the engine heat causes the diesel fuel to ignite. When a glow plug is bad, a diesel engine will produce smoke on startup until the engine is warmed up. The smoke may appear to be burnt oil, but in reality, the unburnt diesel fuel is pumped through the exhaust, giving a cloud of smoke. How to repair a faulty spark plug? The resistance of glow plugs should be checked with a meter to see that they are within specification. The recommendation is that if one is bad, all should be replaced at the same time. See also, how to change spark plugs. 2. Blue smoke coming from the exhaust all the time, stuck PCV valve. If blue smoke appears all the time your engine is running, the first thing to check is the PCV, positive crankcase ventilation, valve. If pressure builds up in the oil, the PCV valve allows this pressure to be released. The pressure is released into the intake manifold, where the engine gets its air to run. The intake manifold is also connected to your engine's air filter. If the PCV valve is blocked, it will continue to mix air with oil and other gases inside the engine. The oil mixes with the gasoline and air and breaks up, creating blue smoke. PCV valves should be replaced at least every 2 years to 30,000 miles, if not more often. With a stuck PCV valve, the throttle body and intake manifold will eventually be covered with oil. However, note that if the crankcase is pressurized by worn engine parts, the PCV valve will do its best to send the engine's oil-air mixture to the intake. Attaching the PCV valve. This should be a simple and inexpensive solution as well. Look for a tube that connects to the intake manifold. Follow the tube until you find your PCV valve. Remove the PCV valve from the tube and replace with a new one. 3. Blue smoke all the time, worn engine. If blue exhaust smoke appears all the time your engine is running, your engine is probably being used. If it's not the valve seals or the PCV valve, the pistons inside the engine move up and down a cylinder. These pistons have metal rings like bracelets around their sides. These rings enable the piston to seal the cylinder. When the cylinder and O-rings are worn, oil can appear from underneath the piston. The oil mixes with the gasoline and air and breaks up, creating blue smoke. The mechanics can check the engine for wear. They remove the spark plug from each cylinder of the engine. Next, they screw a compression measuring machine, compression tester, into each spark plug hole, usually one cylinder at a time. The engine is then returned to the starter. It won't start because there are no spark plugs. The compression tester shows the compression mechanism of each cylinder. The numbers on the compression tester can be checked against the normal numbers for this engine. If a number is lower than normal for a cylinder, then that cylinder is probably worn. If you continue to drive a car that burns oil, your car will eventually stop when the spark plugs are coated with oil and no longer function. Repairing worn-out engines. You can buy fluids that will try to fill worn engine parts. Liquids are usually added with oil. Oil with this treatment is usually marketed for high-mileage vehicles. Sometimes they work and other times they don't. Repairing a worn-out motor is beyond the average person. Usually, most people buy a replacement engine and have it installed. The cost for this item in France by 2015 is around €2,000 and up, depending on the make and model of vehicle. 4. Sudden cloud of blue smoke. Blown turbo. This only applies to cars with turbos. When your car blows a turbo, blue smoke suddenly appears in a large cloud behind you. A blown turbo is either an unpowered seal in the turbo, or the turbo housing has broken. In either case, oil is now leaking into the engine intake. Repair blown turbo. When the turbo is blowing, it's not a good idea to drive the car with the turbo blown. That's because the lack of oil in the turbo will create lumps of metal. The pieces of metal will enter the engine. The engine will be damaged by the pieces of metal. Before repairing the turbo, you need to determine what damage the blown turbo has done. If the inside of the blown turbo hasn't broken into small pieces, you may agree. In this case, you can rebuild or replace it. If the interior of the blown turbo has broken into pieces, you may have engine damage. A mechanic should look at the engine before any money is spent on the turbo. 5. Blue smoke with loss of transmission fluid. Antique cars. Trucks with automatic vacuum transmissions use a modulator to control transmission shifting. The modulator uses the engine vacuum to control it. If the diaphragm or other part of the modulator fails, it allows the engine to suck in transmission fluid. The transmission fluid sucked in by the engine is then burned like oil, causing the blue exhaust leak. Repair transmission modulator. Locate the transmission modulator, remove and replace with a new one. The vacuum line to the transmission modulator can also be replaced if damaged by transmission fluid. Frequently asked questions, FAQ, about blue exhaust smoke. Is blue exhaust smoke always a sign of serious engine trouble? Yes, blue exhaust smoke can indicate serious engine problems, such as excessive oil consumption or piston ring failure. It's vital to diagnose and resolve these problems quickly. How can I tell blue smoke from other types of smoke? Blue smoke has a distinct hue that differentiates it from black or white smoke. Black smoke is generally associated with excess fuel, while white smoke may indicate water or coolant problems. What mechanical tests can I perform to diagnose blue smoke? Oil consumption analysis and engine compression testing are two useful mechanical tests for identifying engine problems linked to blue smoke. Are OBD scanners essential for diagnosing blue smoke? While visual observation and mechanical testing can provide clues, OBD scanners are invaluable tools for reading vehicle fault codes and obtaining more detailed information on problems. Can blue exhaust smoke be prevented by regular maintenance? Yes, preventive maintenance, including regular oil changes and the use of quality fuels, can help prevent blue smoke by keeping engine and exhaust system components in good condition. Does blue smoke have an impact on the environment? Yes, blue smoke can contain compounds that are harmful to the environment. Reducing blue smoke emissions helps preserve air quality and reduce the environmental footprint of vehicles. Conclusion. This conclusion summarizes the various causes of blue smoke, the diagnostic methods available, and practical solutions to remedy the problem. It stresses the importance of regular maintenance and the adoption of preventive measures to keep vehicles in good condition, thereby reducing harmful emissions and helping to preserve the environment. By understanding the nuances of blue smoke, correctly diagnosing its causes and applying appropriate solutions, drivers can not only extend the life of their vehicles, but also play an active role in preserving air quality. Reducing blue smoke emissions is an essential step towards a cleaner vehicle fleet and a reduced environmental footprint. In conclusion, blue exhaust smoke is a clear indicator of engine issues, often related to oil burning or problems with the valve seals and piston rings. Addressing these issues promptly can prevent further damage and costly repairs. Regular maintenance and timely inspections are essential to keep your engine running smoothly. If you notice blue smoke, don't hesitate to consult a professional mechanic to diagnose and resolve the problem effectively. Thank you for watching, and stay tuned for more insights on vehicle care.